Hello students, this is lesson U3A07c. By the end of the lesson, you should be able to say, I can find and apply centroid of a triangle to solve problems. Okay, so in the previous lesson, we talked about two constructions inside of a triangle. It's like it's within the DNA of every single triangle. Within every single triangle, there exists an altitude and a median. So in this lesson, we're going to talk about the medians intersecting. And when the medians intersect, it will form something called the centroid. So what exactly is a centroid? Well, the centroid is the center of a triangle. And the center of this triangle divides a triangle into 6 equal areas. So because of this fact that the centroid divides the triangle into 6 equal areas, it is sometimes referred to as the center of mass of the triangle. And the centroid, okay, can be found by having the medians intersect. So for example, right now, in this diagram that I have illustrated here, segment BE is a median. Segment FD is also a median. I'm sorry, FC is a median. And segment AD is yet another median. Notice how the three medians, they will all come together and intersect at point G. So point G is the centroid. Okay, now it can be shown, okay, algebraically, that all of these areas, okay, as it turns out, the area here is the same as the area here, is the same as the area here, it's the same as the area there. So all of these areas that I am shading in blue, okay, it could be shown that all of these areas are in fact the same. Okay, and I encourage you, okay, as a challenge for yourself, try to come up with a way to explain why are these 6 areas the same. And if you can convince yourself why these 6 areas are the same, then it would make sense that if we were to cut this triangle out and place it on a pin, okay, where the pin, where this triangle is resting on the pin over point G, this triangle would be able to balance itself entirely. Real thing, okay? So that's why we call that the center of mass, okay? Because that is the balancing point, okay? All right, so the main takeaway here, students, is this, that yeah, the center of mass, that the centroid is the center of mass, that's nice and all, okay? But as far as problem solving goes, as far as like the standard that we are trying to hit so that you will be successful moving forward is this, okay? That the centroid will break up the median into a set proportion. I encourage you to maybe think about, okay, just look at this using your eyes, okay? What proportion do you see point G breaking up segment BE? What proportion do you see point G breaking up segment FC? And lastly, what proportion do you see point G breaking up segment AD? So it is important for you to, try to figure this out for yourself internally and try to make that kind of conjecture, because after all, that's what education is. You make hypotheses, okay, and then you try to, test out whether it's real or not, okay. So if you thought about this for a little bit, okay, point G certainly does not break up the medians into equal parts. They don't look like they have the same length, right? So for instance, this line right here, EG, looks to be shorter than segment BG. It looks shorter, okay? And as a matter of fact, it looks like EG looks to be almost, dare I say, half of BG, right? So if you think about this, okay, if I were to put a point over here, another point right there, okay, it looks like almost that that BE, okay, can be broken up into thirds. And if you think about it this way, EG may be a third of BG, right? Or BG may be 2/3 of the entire median. And that is exactly the point, okay? So AG is twice as long as GD. AG is twice as long as GD. BG is twice as long as GE. CG is twice as long as GF. And alternatively, you can think of, oh, that AG is going to be 2/3 of AD, BG is 2/3 of BE, CG is 2/3 of CF. The point is, ladies and gentlemen, I don't want you to memorize, okay, this chart here, if you want to even call this a chart, because it's a lot of information. It looks scary, okay? So I don't encourage you to memorize this more, but instead I encourage you to try to remember this diagram. And this point right here, this point breaks up the whole median into 1/3 and 2/3. That's the way to remember this. It breaks it up into 1/3 and 2/3. So the centroid will be 1/3 away from the base, and it will be 2/3 away from the vertex. This is the way to remember it. Okay? So if something is 1/3 of the entire median and another segment is 2/3 of the entire median, so that means the 2/3 portion must be twice as long as the other half. Okay? Or as the other portion, rather. All right, so let's take a look at an example where we can apply this concept. Okay, so right now I have a U has a length of 3. Okay, the task is to find out what is XA. So having gone through the principles in this slide here, see if you can pause for a moment, okay, and figure out this for yourself. Hopefully you had some time to think about this. So AU is going to be what portion of the overall? It's going to be 1/3 of the overall length. And I know, so if this is going to be 1/3 of the overall length, then we can say that XA is actually going to be twice as long as AU. So therefore, XA must have a length of 6. Let's take a look at another example. All right, so very, very similar. I know that AT, okay, is equal to 2x plus 1, which is this length right there. And WA, which is the other 2/3 portion, is x plus 5. See if you can pause a video to find out what x is, and then what the segments WA is and what AT is. All right, so hopefully you had some time to think about this. Let's take a look. Since A is the centroid, then WT is going to equal to 2/3 of WA and 1/3 plus 1/3 of AT, or WA is going to be twice as long as AT. Since I have WA and I have AT, I can just use this relationship here. So one more time, WA is 2 times AT. So therefore, I can just immediately just substitute that in. X plus 5 is equal to 2 times 2x plus 1. X plus 5 is equal to 4x plus 2. Subtract both sides by 2. I end up with x plus 3 is equal to 4x. Subtract x from both sides. 3 is equal to 3x. Divide by 3. I end up with x is equal to 1. So therefore, I can figure out what AT and WA are. AT will equal to 3, and WA will equal to 6. And that's it.